Lesson 11 for triangles, and in this lesson you learn to find the missing angle measure of a triangle and to classify triangles by angles and sides. Let's take a look at this real world application in engineering. But before we do that, let's find out why this lesson is important, because architects and civil engineers use triangles in building designs. So civil engineers who design and build railroad bridges often choose a truss bridge to span canyons and rivers. This is an example of a truss bridge, okay, and requires less building material than other types of bridges, okay. So if you notice, if you look at the truss bridge, it's made up of a lot of triangles right there. So trusses get their strength from braces from triangles that form triangles. Because triangles are rigid, they are strong. A triangle, therefore, is the definition of a triangle, is formed by three line segments that intersect only at their endpoints. A triangle can be named by its vertices. The triangle shown below is triangle PQR, or triangle or the symbol triangle and PQR. So this is triangle PQR. Okay, the vertices are P, Q, and R. So these are your vertices right here. Okay, P, Q, and R. The sides are PQ, QR, and PR. So this is PQ, QR, and PR. And the angles are angle P right here, angle Q right there, and angle R right there. Okay, there you go. So those are the three angles of triangle PQR. So there's a special relationship among the angles of a triangle, and let's find out what these are. First and foremost, okay, uh, use a straight edge to draw a triangle on a piece of paper. Cut out the triangle and label the vertices A, B, and C, so something like this. So on a straight edge, on a piece of paper, use a straight edge to draw a triangle like this, and the vertices are A, B, and C. Then second step, find out the relationship. Fold the triangle so that the point C lies on segment AB. So you're going to fold this so that point C lies on segment AB, and the fold is parallel to AB. Okay, label angle C as angle 2. So basically what you do in step 2 is this. You fold angle C, point C, so it lies on segment AB right there. Okay, and the fold right there is parallel to segment AB. So angle C now is labeled as angle 2. Let's take a look at step number 3. After you do that, fold again. So point A meets the vertex of angle 2. Label angle A now as angle 1. So what you do is fold A so that the point A, okay, meets the vertex of angle 2 right there. So this is the fold that you do. Fold it, goes all the way there, okay, and we will now label angle A as angle 1. And finally, step number 4, finally fold the point B so that it meets angle 2, and we will now label point B as angle 3. So we get this point and fold it so it meets up with that vertex, and this is how it's going to look like, something like this in step number 4. Now the special relationship is as follows. What do you notice about the sum of the measures of angles 1, 2, and 3? Okay, this suggests the following relationship. Okay, now if you get the sum of angles 1, angles 2, and angle 3 right there, okay, you will notice that it will form, or it will have a sum of 180 degrees. Okay, so let's find out that is your, okay, right there, that forms 180 degrees. This is angle 1, angle 2, and angle 3. So if you notice, they're all supplementary to each other. Okay, so therefore the sum of their angles is 180 degrees, which brings us to the angles of a triangle will have a sum of 180 degrees. Okay, and let's see how that works in example 1. So in triangle CAT, The measure of angle C is 47 degrees. The measure of angle A is 59 degrees. We want to find the measure of angle T. So we estimate first. So estimate that 50 plus 60 equals 110. And since the total sum of the angles is 180, we subtract 110. So it's around 70. So the measure of angle T is about 70 degrees. Okay, let's find out the true measure of angle T. So we know that the measure of angle C plus the measure of angle A plus the measure of angle T equals 180. This is according to the sum of the measure of angles of a triangle, which is 180 degrees. Okay, and we simply substitute the value. We know that the measure of angle C is 70 degrees, 47 degrees, I'm sorry. The measure of angle A is 59 degrees, but we don't know the measure of angle T. Okay, and then we simplify that by adding 47 and 59. We end up with 106 plus the measure of angle T equals 180. And in solving one-step equations, we subtract 106 to both sides of the equation. Now the measure of angle T equals 74 degrees. Okay? Let's take a look at example number 2. If it's here, if it's not, it's going to be on the other page. Yep, it is. Okay. Angle 2, connection to algebra. So the relationships of the angles in a triangle can be represented using algebra. Okay, and let's take a look at this one because you will have a problem in the book and a problem on the test that will be similar to number 2. So listen up. Okay, understand this, rewind, pause until you get it. So find the measures, the measures of the angles of a certain triangle are in a ratio 2 to 3 to 4. So we want to find the measure of each angle. So what does that mean? Okay, if we let 2x represent the measure of one angle, and 3x represent the measure of a second angle, and 4x represent the measure of a third angle. Why is that? It's because you have a ratio of 2 to 3 to 4. Okay? So from there, we simply add 2x plus 3x plus 4x equals 180, the sum measures of an angle. Okay? And then we simplify 2x plus 3x plus 4x, which will give us 9x equals 180, and divide both sides by 9. End up with x equals 20. Okay, so if we get that 20 and go back to our let statement of 2x, 3x, and 4x, we find that the measures of the angles are 2x equals 40, 3x equals 60, and 4x equals 80. So the measures of our angles are 40, 60, and 80 degrees. We can check this, okay, by adding 40 plus 60 plus 80, which will give us 180 degrees. Okay, and let's take a look at this last thing. In this particular lesson, the triangle can be classified by its angles. Every triangle has two acute angles. The third angle can be used to classify the triangle. Okay, and before we do this, the secret word of our video for today is LeBron. The secret word is LeBron. Okay, so again, a triangle is classified by its angles, and every triangle, not just one, has two acute angles. And the third angle is the one that classifies our triangle. For example, if you have an acute triangle, this simply means that you have three acute angles. Remember the definition of acute. Okay, greater than 0, less than 90 degrees. Okay, so that means this is an acute triangle because you have three acute angles. And if you have a right triangle, you still have two acute angles, but one right triangle, which has a measure of 90 degrees. And if you have an obtuse triangle, you still have two acute angles, but one obtuse angle. Remember The definition of an obtuse angle is angle that measures more than 90 degrees but less than 180 degrees. Okay? And after classifying our triangles by its angles, we can also classify it by in terms of uh, the congruency of its sides, or the number of congruent sides. Okay? If a triangle has three congruent sides, meaning all the sides have the same measure, it is considered to be an equilateral triangle. If the triangle has two congruent sides only, it is an isosceles triangle. And finally, if the triangle has no congruent sides whatsoever, it's called a scalene triangle. Okay? And that's the end of our lesson. Thank you for watching.